Well, anyway, welcome everybody tonight to our third, you think? Third remote one, quarantine meetup. I appreciate everybody coming out. Excuse me, just to right at the beginning, we have our code of conduct. Cleveland React is a safe and friendly place for all people, and we're not going to tolerate any behavior that makes people feel unsafe. So if anybody has, so please, be cool. If anybody experiences anything that makes them unsafe, please reach out to me or John. You can hit us up on the meetups, on meetup.com, private chats. Our email is hello@clereact.dev. You can reach out on Twitter, or Twitter, or on Slack. Direct messages, anything is fine. There is a fly flying around my head, so that's going to be great.
We can't see it though.
Oh, good. Yeah. Moving on. We just scheduled our next .js talk. It's on June 11th. James, actually, who's here, I think James wants your wave. Yep, there you go. James is going to do a talk for us on Next.js in a couple weeks, which will be cool. Same time, same kind of deal. So thank you, James. James volunteered for that, so that was awesome.
I just made a weird symbol. Like when you do the grid view, is it the same grid for everyone?
I don't think so.
No.
I think
okay, because that wouldn't mean anything then for me to point where you are on my grid. So
yeah,
never mind.
You're pointing at Cam for me. So.
Okay. Yep, that doesn't make no sense.
We knew what you meant though.
We had like a persistent Brady Bunch thing going on, but
right.
Apparently it's much more difficult than that.
Right. Maybe I should be able to like just draw pictures on people's, as like the host. So we're always looking for speakers. So we've been really lucky, and we've had a whole string of really awesome speakers that I have not had to twist their arms very hard. I would love to have some more people speak. John and I, we would be glad to, help you workshop something if you want to, if you have an idea and you'd like to put it together. We are open to different formats, stuff like that. So please hit us up, privately or whatever, if you're interested in speaking. We'd love to have you.
Just in case you're not familiar, so typically we do like one main speaker kind of talks for the night, or for an hour and a half or something like that. It can be a lot of time to kind of feel like you have to fill. There are also like small sessions that we could do. You could kind of group a couple of different people together and do something more like lightning talk related, where maybe you're talking 5 minutes max, kind of help you figure out, basically scope your time and figure out a topic that you might find interesting or something like that. We've had somebody actually do a remote workshop as well, if you weren't able to attend. I think that was the last thing that we did. So lots of things. So if you're interested in anything, feel free to start a conversation.
Absolutely. We announced our next event. Does anybody, this is a good chance for anybody, if you'd like, if anybody has events that they would like to, promote or let us know about, we'd love to hear it. You can talk now if you'd like, or I probably should have said this before, but or you can drop it in our Slack. I put a link in the Zoom group chat. We're going to try to use, we're trying something a little bit different. We started a new Slack channel just for the group, so that we're not taking over, general purpose rooms in the Cleveland Tech Slack. So if you guys want to jump in there, if you're not already, we're going to try to use that for, in talk chat tonight, and then continuing on. That'll be a good place to get, excuse me, to get announcements, and we can, post discussions about the, events and questions, all sorts of stuff like that. So the link for that is in the Zoom group chat. So go ahead and jump in there if you are interested in that. Also, if you have any announcements, links, whatever you would like to post, go ahead. Feel free to post them there. Treat that Slack as our, event Slack for tonight.
I got an event or a thing.
Yeah, John.
So it's not necessarily React related, but Dan did this a little bit with the React group, and I'm sure that we'll probably do more of it in the future. But every week I do a Thursdays at noon. We have like I call it a water cooler chat, and so in the Rust room inside the Cleveland Tech Slack, it's just come as you are, say hi, talk if you want to, or lurk if you want to. And we basically just talk about whatever people want to talk about. So there's no agenda or anything like that. But we do those on Thursdays at noon. Unless I have a client call, in which case it all gets upheaved and we have to figure out what to do after that.
Absolutely. Yeah. And we've done those React chats. I took a couple of weeks off, but I'm planning on getting them started again next week. So I'll post those on the meetup, like normal. And so keep your eyes out for that too. Does anybody else have anything they'd like to add before we kind of get to Dylan's talk? Okay, cool. So Dylan Pierce is the head of trust and security at RVShare. Full stack developer. He's worked in a variety of languages and worn many hats across the startups he's worked with for the better part of a decade. Besides being a general internet plumber, he enjoys learning about catching and preventing fraud. His latest project, Verdict, which is getverdict.com, helps Shopify merchants increase revenue by preventing chargeback fraud. I actually checked that out for a while today, and it seems like a really cool product that the chargeback fraud is a big problem if you haven't done e-commerce. So it's a pretty cool project. I just before we get started, extra thanks to Dylan for volunteering to do this talk, and I hope you guys enjoy it. Dylan, go ahead.
Thanks. Let me get my screen shared here. All right, I'll share the whole desktop. Okay, I assume you guys can see this, but yell at me if you can't. All good? Awesome. So I just wanted to spend some time today to teach you a little bit about WebSockets if you've never used them before. They're a really nifty tool, and they can add extra capability to your project that otherwise can't do with APIs alone. So like Dan was saying, I'm head of trust and security officially at RVShare, but I do all kinds of stuff. I've built tiny houses and smart meters for a time. I just like building stuff in general. So the goals of this talk, I want to teach you what WebSockets are in about half an hour and empower you to use them in your projects going forward, at least know just enough to be dangerous. And I'll also share with you some of the pitfalls I've learned by overusing them in my past and when to use them the right way. And identify kind of like the right problem for the solution, not vice versa. So you've seen them before, like all over the web. Love it or hate it, the Facebook kind of like pop up for notifications. I'm addicted to it still. So, I mean, like that's what's powering that little notification bell. It's not like a API type thing. It's a WebSocket being pushed from the facebook.com to your client. It also powers a lot of cool things like real-time dashboards, which are pretty nifty. Sometimes people use it for IoT communications. So if you're pushing events to like a Raspberry Pi or some kind of small computer, but that's a whole different story, and I definitely do not recommend that. And then another one, since this is the React group, behind the scenes with the Webpack dev server, whenever you like save your project and it magically just refreshes the page, it's actually a WebSocket event that reloads your script bundle being pushed to your browser. So it's pretty cool. It's in the background all the time, whether you know it or not. So what are WebSockets from a 1,000-foot view? It's a protocol for transferring data from your client, aka React, from your server and back and forth. So it allows, it's kind of like APIs and XHR requests, and that you can transfer data without refreshing the page, and provides a more seamless experience for your end users. And you can send text and binary data, but I've never seen anybody use the binary data functionality. It might be out there somewhere. But this GIF at the bottom does a pretty cool job of explaining it. Under the hood, the client opens up a HTTP request that actually says upgrade and use WebSocket. And if the server supports it, then they go and they open up a new WebSocket band, and they can pass events back and forth. Here it shows like the server pushing like 3 events from one request, but I'll show in more detail after this. So yeah, so WebSockets is not like a something that runs just on the client or just on the server. It's a protocol. It's a networking protocol between the two. So I hear protocol being thrown around a lot. It's a fancy nerd term, but it basically just means it's a predetermined set of rules for behavior. So like, for example, my favorite place to go get food is Taco Bell. You have this protocol with the person at the front of the counter, and you know, go through this whole series of steps, and you both understand before you start the interaction what that looks like. They ask you how you doing, you order beef chalupa, they ask you for money, you give them the money, they asynchronously give you the chalupa when it's ready. And that's what a protocol is for people. So a traditional API consumption, thing you'd use from day to day, if you're using like Axios or Super Agent or any kind of like RESTful API, it's a pool model. So you as the React app are asking the server when you need data. And then that server, when it can, will send that data back to you. It's a one-way control system. The API doesn't boss you around. It just waits for instructions based on the requests that your user asks you. And it can't handle things that are out of band, which means like if something happens, like say your app supports Twilio and you have texting or calling, that's out of band from the HTTPS communication between you and the server, or you and the client. So there's no way to communicate and break through those 2 different bands with traditional APIs, unless we're talking webhooks, but you can't webhook to a client that's a browser. So it's kind of some limitations of the traditional APIs. So here's my simple little example. I'm sure you guys have seen this 100 times. Here's a chat API endpoint that we get. We give this function get messages a chat ID. It uses our API and it pulls messages down. And over here on the left-hand side, the blue icons are React app, and on the right is this orange cloud, which is the server. So we ask the server for this information. It gives us back a payload. In this case, it's an array of messages like, hi, how are you? So the problem is, let me go back again. The problem is, if you're using a traditional API and there's another person in the chat, how do you know when that person said anything? How do you know when to retrieve information? So back in the day, when I first attempted a chat app, I would just use set interval. And I would say, okay, well, I'll just have it ask the API every second. It's real-time-ish. So as long as the user was on that page, their network tab would just be like infinitely scrolling down with these requests for messages from the server. And this is just a waste of resources. I mean, you might as well just plug in a Bitcoin miner on your client's browser, because this thing is just going to chew up resources. It's going to use up data. If they're on a phone, it's going to chew up their data plan. It's just mean. And this is what WebSockets is really built for. So yeah, like I said, instead use WebSocket. So WebSocket just totally turns this diagram upside down. Instead of having a traditional request response kind of like back and forth, instead you create a connection, and then within that connection you can send events back and forth. So here we have 2 different clients both talking to the server at the same time, and each can send messages to the server. And if you can see on the bottom portion on the right, you can see that the server will actually push the event to the client, which isn't possible in a regular API. But is exactly what WebSockets are built for. So you can think of WebSockets in terms of like sessions. APIs you think of in terms of one client, one server, and that's how you frame the communications between the two. With WebSockets, you can have one server talk to many clients at one time. and broadcast messages to many or some of them or just one of them. It doesn't limit you to just one-to-one, a one-to-one relationship like regular APIs do. So I made a couple really quick examples. I hope that this kind of clears things up and makes it a little bit more practical for you to use. So this is, I'll put this link in the chat. This might be even easier just to play around with. So this is a super simple Express app that allows you to create a WebSocket between the client and the server. So I'm going to show you real quick the server. So I hope you guys have some experience with Express, but it's just a simple HTTP library that exposes or like creates a server that you can serve HTML or serve JSON, whatever you want. So here we create a regular Express app, nothing fancy, but then we wrap the HTTP, like built-in HTTP module with this server, and then pass it to the WebSocket server. So essentially you have two different servers. You have one that's handling HTTP requests and then one that's handling WebSocket requests. So I named this WebSocket server WSS, which is just short for WebSocket server. And this is the on connection event. So normally you can see down here where it says app-get. That's kind of how you register a route. With WebSockets, instead you have columns like jQuery-esque event handling. So on a connection with a server or with a client, you create a socket, and that's what's passed into the first argument. And then we'll just, as soon as they connect, we'll send them an event, send them a message and say, hey, this is the server, we're connected, we're good now. And then we can register more events. So now from the server's perspective, when the client sends a message, we can do cool things on it. We can respond to it. So this is kind of, this event right here is more similar to the traditional API request or regular route in a traditional MVC or server-side app. So here we get the message from the client, we'll log it, and then we'll just respond to it and say, hey, we got your message. This is what it looked like from my side. So from the front end, I just have this really, really simple ping server button. And all of the JavaScript is just vanilla JavaScript. You don't even need to import a module. WebSockets are built right into the browser. And it's supported by all modern browsers. So here's the client consuming the WebSocket. And we tell it, this is the URL where the WebSocket's exposed. And then we'll add just like the client, it's all event driven. So when the connection is opened, we'll log it onto the browser. We'll say, hey, it's exceeded. And then we can hook up this button or hook up this function to a button. Let me just show it real quick if you haven't started playing with it yourself. So these two events were automatically logged immediately. And on the server side, we can just take a look here. It should have logged the event, or that's the terminal. Terminal is different from the logs. Hold on, Zoom's blocking my view. Jeez. Ugh. I really like glitch, but sometimes it glitches. Here we go. So this is the actual log like you would see in your terminal if you're running Express in your terminal. So we received a message from the client, hello server. That's because somebody pushed the button. we're all sharing the same connection here. Every single connection is treated the same. So I'm sending a message. I sent 3 messages, and it came back on the server 3 different times. So like an API response, you would do an async thing here, right? You would say like .then, do something. But instead, it's all out of band. We sent this message, hello server, and then when the server responded to us, it fired off this function here instead. So it's like totally separate. They're not even in the same function, the sending and the receiving. Whereas with APIs, you would have this chain of events. You would say on message received, then, or catch if it's an error, and then do stuff. But here it's just totally separate, not even the same function, like I said. So this is a really simple example. Feel free to refresh the page and see how it changes the, you can see on both sides. So if you go into here on the console, you can see that it does log the event. Hi there in the WebSocket server. To get even more of a clue, there's actually a built-in WebSocket connection tab in Chrome DevTools. So this WS portion right here. So you can click into this, and this is the initial message that creates the WebSocket connection. And you could see the first message was down, meaning from the server down to us, and this was the message. So we click this button, we'll see that we sent a message up, it received it, and it responded, said, hey, I found it, I got your message, this is coming back down. So it's pretty useful. You can kind of see how the WebSockets are going back and forth, their messages going back and forth, which direction they're going. It's pretty useful for debugging. So that's a nifty little example. The other one is a little bit more advanced. This one instead is the whole shebang. It includes React, it includes Express, it includes WebSockets. Does more like real life broadcasting. And I'll show you what I mean by broadcasting in a second once I open up the link. Here we go. Here, edit project. So the last example I showed you was just between one server and one client. This example is one server and many clients, and you can broadcast to everyone attached to the same web page, which is crazy if you really think about it. But this is how chat apps really work under the hood. So we'll go back into server, the server.js file. So it's basically the same setup. You got your Express app, we create a WebSocket server, we pass the HTTP server to it, and then we have the regular on connection route. We send an initial event saying, hey, welcome to the chat. But what's different is instead of sending the message on the socket, we'll go through each of the clients currently attached to the WebSocket server, and we can send it to all of them in this, like an extra line of code, which is awesome. So in this example, we will just open this up. I think you guys might be able to just go right to here. So this is the actual hosted web page. If I can type, open new window, copy this. So this is the hosted chat page, and it actually works. You can see that, you know, you could change your name, you could send a message, and it actually broadcasts to everyone that's attached to the channel. CSS modules for life, I love it. So yeah, let's go through and just kind of talk about the different events that are happening here from the front end perspective. So if you go into the app components chat, you can see it's the same process. Outside of the React function, we'll just create a WebSocket connection. No special module required. It's built right into the browser. This will represent our socket, our individual socket from the perspective of your browser to the server. And then I just created some, you know, simple states like current message that you're typing, messages that are available in the state, and then lastly your name, which I just created a random name for you when you come in. And then this is the function that actually sends the message. Pretty simple. You take that socket connection, I prepend your name to it, send the message, and then here's how you use effect with sockets. So you don't want to just have the socket events registered in the function, because then you'll have some crazy re-rendering problems. I would just do it like the API call style, where you just pass an empty dependency array, so that way it only loads once, and you register these events only once. So here you have on open, you gotta tell the group, you gotta tell the server, hey, I'm connected to the chat. So what happens is that message name connected to chat. We'll go over here and then hit this event. And then it just sends it to everybody. It's that simple. Same thing with a regular message right up here. The other cool thing that's a little bit different, there is a event called before unload that sometimes works, sometimes doesn't, but it's a way for you to hook into when people leave the chat or close the tab on their, refresh or close the tab on their browser. So you can just kind of refresh the page. That's the wrong window. And it should say on someone else's view that I left. So we'll say leaving chat. Bye. So if you're on this chat right now, when I refresh the page, it'll say I left the chat and then I'm connected as a different user. So it's kind of a nifty way to, in real time, tell if your users have left your site or not. But I've heard it's not like really reliable, but it's kind of cool. The other last thing is on message. So yes, this is the message. This is the socket that receives a message from the server and then just shows it, sets the message into the internal state. And then you can see it on the front end of your app. And nothing really special here. Just the messages array being mapped over creates a list item and there's really, really simple form. I didn't want to make this any more complicated than it needed to be. So yeah, the real focus is on learning what these 3 event listeners do. So that's kind of fun.
Hey, Dylan, I got a question. If you're doing questions, where did you bring the top level socket request in from, or create that? So it looked like you were using it in your use callback and stuff like that. But where did you pass that in from? Like where you initiated the React app? Sorry, on the React side at the component that you were looking at. It looked like you were. Where do you do? Yeah,
this one?
Gotcha. Okay, thanks. Cool.
Yeah, I do it outside of the chat. I've tried this before. I tried putting it in use effect before.
Yep.
It just doesn't really.
Yeah, it gets a little weird. But this way you would be able to pass your socket around to different components as well if they needed to set up their own listeners and things, right?
Exactly. So if you're passing the socket around, I assume you can wrap it in a provider and then inject it. But I've never actually tried that. It might be something worth trying out.
Yeah, I did a whole bunch of really weird stuff with you're good. It just muddies the water a whole lot on these conversations, but yeah, it gets interesting.
Yeah, I can imagine. So that's another caveat to that that it's not like a proven thing, especially with React, but it's still really nifty and good to know. Let's see here. So to continue, that was kind of like the demo part of this. Wrong button. So the two really like key objects to know, that's all you need to know, is there's a WebSocket server that's normally called WSS if you ever look at source code, and the socket, which I typoed here, it's actually called WS most of the time when you see it. So that extra S is like huge when you're looking at source code. I don't know why they do it that way. I just call them socket and server. So the server has context of every single connection attached to it. It's hosted up on Node or Ruby or whatever you're using for your server side, whereas the socket is only representative of one connection between the server and one of the clients. So that's the big difference. So that's why when you're looking at the server.js, you'll see it all wrapped in one connection and it passes one socket instance. And when I'm broadcasting, I have to access the server instance because that individual client inside of that function doesn't know about everybody else. You have to use the overall manager object to find that stuff out. So like I said, WebSockets interface is an event-based type thing. I showed you a couple of the events on open, message, and close. There are more. There's one called upgrade, which you use to provide authentication for. That's a whole different story. But before open happens, there's that one request that's made that basically tells the server hey, I'm available to take WebSockets if you are. And then that's called the upgrade because it's upgrading the communication protocol to WebSockets. And that's where you would do authentication if you're doing authentication. So that one's pretty cool. But these are the 3 basic ones will get you really far if you're making real-time apps. So why not use them everywhere? The authentication experience is not great. There is an Express plugin. It's non-spaced, but good luck finding anything that's like battle tested and is normal. I have yet to do that, but I'm sure there's ways to do it. Documenting is really weird to do. When you're thinking in terms of RESTful or even GraphQL, documentation is huge, and it creates like this topology that you can understand, and you can kind of map out what's available for you to interact with and how to change. Like, for example, it's RESTful. You can get, post, delete, patch. Whereas with WebSockets, you have one path, and that's it. Like you have to, all of your events would have to be like if else on messages, or like sending a JSON object that's recognized in a special way, with like by type or something like that. So it's kind of odd. I think it more of is like a fire hose. Like you should make WebSockets when you're allowed to be flexible with the data that's coming back and forth, not when it needs to be structured. And last but not least, like I said, it's like jQuery for data transmission. Like it's based on events. It's not super expressive. So just to make the difference a little bit, side by side between the two. So HTTP APIs are route-based. They're pool only, and the communication's only between one server and the consuming client. WebSockets, on the other hand, it's based on events. You only have 3 major events you can work off of. It's 2-way, aka full duplex, and the communication isn't constrained to just one client. You could broadcast to many clients at the same time. So it's a one-to-N relationship, or one-to-many, versus a one-to-one with HTTP APIs. So if you want to learn more about this stuff, there's a really popular library called WS. This is probably the most popular node-based repository. There's a couple other options. There's like Socket.io, but I really enjoyed this one. I used to use Socket.io primarily. I just switched over to WS for this example, and it was way simpler. And there's also the browser side, API documentation by Mozilla. They do a great job. They also have a lot of links to other compatible libraries on the server side. And then this one guy made a pretty cool list of other resources about WebSockets that are don't just include like libraries to use, but also papers on showing when and when not to use them, security. You might have seen the Hacker News post recently about how insecure React DevTools is, and how someone could theoretically steal your code via WebSockets because there's no authentication on it by default. So some of those papers are linked there, which is pretty cool. And that's it. So I hope you got some value out of it. I hope that this gave you a big overview of how to use WebSockets. They're not that scary, and they're useful to you in the future. Any questions?
We had one question in the Slack room, if you still have that open.
Yeah. Can 2 clients talk to each other somehow without going through WebSockets server? No, because the WebSockets server is findable, as in you connect to the DNS through DNS. There's no way for you to talk peer-to-peer. There is BitTorrent on JavaScript now, so you technically could do that peer-to-peer, unless you know of other protocols. Even then, I think you still need an index file. So no, at the moment, no. I'm sure there's peer-to-peer network protocols that are lower, but not on the browser, as far as I'm aware. No.
I actually had a question about on the server side, when you're broadcasting back to multiple clients, and in your code, you just had that for loop, like the for each from all the clients. Is that just like the standard way to do it? I was just like wondering if that's a performance concern, if it ends up being, you know, like a bunch of clients connected at the same time, or if that's just the standard way of doing, you know, like if that's just like the normal way of doing it, and you don't have to think about that until you're, you know, Facebook or something.
Yeah, as far as I know, that's what you do. And
Yeah.
even to take a step further, if you have multiple WebSockets on like multiple paths, so you can dedicate a socket to a path. You could say /chat is this WebSocket server or connection, and you could say /notifications is another. The client or the WebSocket server is not able to differentiate between those two paths in the .clients method. So you actually have to like filter out before you even do that for each. And you have to do it based off the route.
Yeah,
So
yeah, that was actually going to be my second question was yeah, if you have different, you know, use cases on one server, if it makes sense to make multiple sockets, you know, as opposed to just like trying to pipe everything through like one single.
that WS library has examples of that case you're just talking about. And it has a case of multiple servers, multiple WebSocket servers with one HTTP server. But this guy right here should do it. Any considerations with, Robert asks, any considerations when using WebSockets with React Native? I would assume not. It's at the networking layer. I think you should be fine, but the WebSocket client might need to be a React or a React Native library, because I'm not sure if the React Native will emulate the browser that far. You might have to use a special client, but I assume that's been talked about in the React Native world.
Are there any like scale issues as far as like opening a ton of connections, or is it similar to like a database connection where just make sure you close them when you're done?
That does handle automatically closing when the client stops being connected. That's another layer that's lower. I don't understand.
Sure.
I don't know if it pulls underneath the hood, but I don't think it does. I don't think there's any performance loss in having many connections open. I don't think they're actively being monitored.
Mhm.
But there's events being fired that say, "Hey, I'm closing." You know, kind of like an Etch-a-Sketch. Like it only use state when it's changing. Cool.
Yeah, so I'm mostly familiar with it on the Rails side. So they have some wrapper libraries around it, so you can communicate between the front end and the back end and stuff. And it can definitely become a performance problem depending on the server that is on the back end, because the server is keeping all of these different connections alive and keeping resources allotted to each of those. So depending on how much information you're actually bringing into memory and keeping around per connection, it can get interesting. It also makes you susceptible to a little bit of a different security kind of hammering attacks and stuff like that to try and overwhelm your server. But I mean, if you're having those kind of conversations, then there's other stuff that would that could get you as well. So
Yeah, I would hope you'd have your WebSocket functionality behind a authentication wall that's not involved with WebSockets.
yeah. It just gets interesting. So like I think the Rails side does it with the upgrade request to the server passes a cookie, which then uses that to figure out who that client connection would be and stuff like that. But you can still start a lot of different connections, or in the connections that are there, like especially in like Ruby land and stuff where we never think about memory. You can make each process hold a lot of information, which then makes your server hold a lot of information, depending on what you're trying to do.
Mm-hmm. Yeah, I would not want to see this WebSocket scale. That would be a whole different problem. So I would keep it to simple stuff like notifications, some chat, but even chat would be let the experts do that. But yeah, well, thanks for letting me talk and share that. It's pretty cool. I hope you think so too, and I hope you got something out of it.
Yes, thank you, Dylan. That was awesome. I was, yeah, that's always been one of those things that I've sort of avoided because I didn't, totally understand what it was. So I found that to be very enlightening myself. So thank you again, Dylan. Thank you for volunteering to talk. We very much appreciate it. Thank you everybody for coming and hanging out with us tonight. We yep, I said it before, but we have our next meetup scheduled in a couple weeks, and James is going to be running us through some Next.js awesomeness, and we can keep your eye out for another React chat probably scheduled for next week. We're gonna try to keep this Cleveland React Slack room going a little bit, so stay subscribed to that, I guess. And John, do you have anything else to add?
Oh, I'd say so Dave Kiss is usually the one that normally does this, but I think it's kind of cool. If you just get bored sometime, feel free to drop like a programming example exercise thing into the room sometime. Like they're just kind of fun little things to play through and stuff when you're trying to get through the monotony of the day. But yeah, there's a whole bunch of stuff. So like if you're trying to learn something new or you're stuck on something or whatever, like feel free to bring it up to the group and stuff like that. Everybody's pretty helpful usually. So
Absolutely.
thank you very much,
I'll put all
Dylan.
Sorry, go ahead.
Oh no, you're good. Go ahead.
I was just going to say I'm going to put all the links to the app into the presentation and to like some more explanation into the Slack channel. If you want to just look at it later after, forgetting what I said.
Awesome. Yes, I will appreciate that. All right, cool. Well, if nobody else has anything else they want to add, everybody have a good night and stay safe, and we will see you guys next time. All right.
Bye. Thanks, guys.
Have a good night.
Take care, everybody. Thank you, Dylan.
Thanks, Dylan. Yeah, my internet actually worked tonight. That was exciting.